Good morning, my name is P. Jahnavi. I am studying BTech second year of ECE branch. Now I am discussing about the subject switching theory and logic design. In this, I am discussing about the topic of flip-flops. First, we have to see introduction to flip-flops. First of all, a flip-flop is a sequential circuit, means flip-flop is a memory element which is used to store single binary information, either 0 or 1. The flip-flop maintains a state until directed by input change to the state. Basic flip-flops are constructed using four NAND gates or 4 NOR gates. A flip-flop is known as basic digital memory circuit. First, sequential circuit means both combinational circuit and memory element is called sequential circuit. In this, flip-flop is a access memory element. It has two states, logic 1 and logic 0. Logic 1 means high and logic 0 means low state. The digital circuit is a flip-flop which has two outputs and are opposite states. It is also known as flip-flop is also known as bistable multivibrator. This is about the introduction to flip-flops. Next, types of flip-flops. There are 4 types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. SR flip-flop means S means set and R means reset. In JK flip-flop, JK means Jack Kilby flip-flop. D flip-flop, D means data or delay flip-flops. T means toggle flip-flop. First we have to see what is SR flip-flops. SR flip-flop. This is the block diagram of SR flip-flop. Here the inputs S and R. S means set, R means reset, and here clock is given to the circuit. This clock is used to control the operation of flip-flop, and Q and Q bar are the outputs of the flip-flop. Here preset and clear are the asynchronous input. Preset means 1, clear means 0. Preset is active high input, clear is active low input. We have to see the operation of SR flip-flop. In the flip-flop, with the help of preset and clear, when the power is switched on, when preset is on, power flip-flop is on, and clear is on, flip-flop is off state. The states of the circuit keeps on changing. This is it. It is uncertain. It may come to set q equal to 1 or reset q bar equal to 0 state. In many applications, it is desired to initially set or reset the flip-flop, that is initial state flip-flop that needs to assign. These things is accomplished by the preset and the clear. Set means output q is on, and clear reset means q bar is off. Here preset means active high means flip-flop is on, and clear means active low, flip-flop is off. This is the circuit diagram of SR flip-flop. Here we take 4 NAND gates. Here the input of the circuit First input is S, and next input is clock, and next NAND gate R is the input, and clock is combined to same to the two NAND gates, and the output of the S is Q, and the output of the R is Q bar, and Q bar output is connected to Q, and Q output is connected to Q bar. This is the truth table of SR. SR are the inputs, Qn and Qn plus 1 are the outputs of the SR flip-flop. Here when no supply is applied means 0 0. The output is also 0 0. When no supply means output is also 0 0. Here also we have to take two inputs means 0 0 0 1 1 0 and 1 1. We have to take both when reset on, when clear on. First 0, when we take 0, Qn plus 1 means next state, present state is 0. Qn plus 1 means next state is also 0. Again we see 0 0, and here present state is 1 and next state is also 1. 0 1 input and present state is 0, next state is also 0. 0 1 is again 0 1 input, present state is 1, next state 0. Here we take 1 0 and present state is 0, next state is 1. Again we take 1 0, present state is 1, next state is 1. Here 1 1 means no use, both no reset and clear on at a time, because there is no use when the inputs 1 1. Here overall truth table of this circuit is here. This is reset. When reset is on, the output of the flip-flop is 0. When set is on, the output of the flip-flop is 1. This is all about SR flip-flop. Next, JK flip-flop. In JK flip-flop, basic structure of the flip-flop, which consists of clock, clear, preset. This is the block diagram of JK flip-flop. Here JK are the inputs and clock is the output. Preset and clear are asynchronous inputs. Preset is active high and clear is active low. And Q and Q bar are the outputs of the flip-flop, JK flip-flop. This is the circuit diagram of JK flip-flops. Here JK are the inputs and clock is also control signal. And Q and Q bar are the outputs. And JK flip-flop is connected to Q bar means K flip-flop. K input NAND gate output connected to output, and K is connected to Q means J output. This is truth table of JK flip-flop. Here JK are the inputs, Q1, Qn and Qn plus 1 are the outputs of the flip-flop. Here also two inputs means 4 combinations 0 0 0 1 1 0 1 1. Here 0 0 means we have to take both clear and preset. 0 0 means present state is 0, next state is 0. 0 0 inputs, present state is 1, next state is 1. 0 1 means present state is 0, next state is 0. Again 0 1, present state is 1, next state is 0. Again 1 0, present state is 0, next state 1. 1 again 1 0, present state is 1, next state is 1. And 1 1, present state is 0, next state is 1. Again 1 1, present state is 1, next state is 0. This is all about JK flip-flop. In this JK flip-flop, when J and K both are set equal to 1, the output of the flip-flop is toggling. That condition is called race around condition. Q equal to 0 and Q equal to 1 will change immediately. Means output of the flip-flop is toggling. That condition is called race around condition. D flip-flop. The D flip-flop consists of D flip-flop means data or delay flip-flop. The D flip-flop consists of a single data input and clock signal and two outputs Q and Q bar. The complement of Q. Block diagram of D flip-flop. This is the input D and clock signal is applied. Preset and clear. Here outputs Q and Q bar. Next circuit diagram of D flip-flop. Data means or delay means complement of the input. What is the data means what is the data present in the and output also what is the input present in the data that is appear at the output, and here data is complemented and is connected to second NAND gate, and the output Q bar is connected to clock and Q is connected to clock and Q bar is connected to Q. This is the block diagram. This is the truth table of the D flip-flop. Here Q and D are the inputs and Q of T plus 1 is the output of the flip-flops. Q is 0, D is 0. What is the input combination present in the data that is appear at the output? Here data is 0 and Q of T plus 1 is 0. Here data is 1. Here also data is 1. Output is 1. Here data is 0 and output is 0. Here data is 1 and output is 1. This is the T flip-flop. In the T flip-flop, this is the block diagram. T and clock are the inputs. Preset and clear are asynchronous inputs. Q and Q bar are the outputs of the flip-flop. This is the circuit diagram of T flip-flops. Here four NAND gates are taken. Here the T is the input combined to the both NAND gates, and this is clock signal, and this input is connected to Q bar, and this is input is connected to Q. This is the truth table of T flip-flop. And Qn means present state, Qn plus 1 is next state. Here 0, present state is 0. Next state is also 0. Here 0, 1. Here the complement of T is appear at the output. Here 0, Qn is 1 and next state is also 1. Here T 1, Qn 0, Qn plus 1 also 1. Here T1, Qn 1, Qn plus 1 0. This is all about the flip-flops, 4 flip-flops: SR flip-flop, JK flip-flop, D flip-flop and T flip-flop. Thank you.